Okay, welcome everybody. My name is Hylke. I work for Codecentric, and I'm going to talk about implementing DevOps at Metro. First, I would like to thank the person, Paolo, for lending me his presentation. But short info about me. I'm working for Codecentric about 3+ years. Most of my work I do in the continuous delivery in DevOps space. Sometimes I help out testing, but also architecture and programming. There's some skills I also have. And working also in craftsman labs and garage. Those are more innovation products that we're currently working on from Codecentric. Maybe take a look into it and give some feedback on it. What I'm going to talk about is first of all the customer. Metro is a very interesting customer in order of size. Then I will give you a picture about the problems we are going to solve and the request the customer has from a non-technical standpoint. Then I will take a look into the architecture we're going to build up, and then talk a bit about responsibilities. And in the end, I will talk about solutions, do a short walkthrough, how I solve some or certain issues, and I would like to finish off with some tips and tricks I picked up along the way in such an environment and where the limitations lie. It's always a good thing to know where you're going to run into. And the last bullet point I missed, I finished the job a few months ago, and a lot has changed in the world in a few months that really affects the things we have set up. And I want to visit those solutions as well in the end. So, first of all, Metro. Metro is a very big company. It's almost 250,000 people in 27 countries. They have brands like MediaMarkt, Saturn, Kruidvat, and so all all familiar in the Netherlands, but also there are a lot of I think there's about 100 brands under the Metro flag right now. But they have a very interesting problem space. They have tens of or maybe even hundreds of customer databases, and all these brands and all these in all these countries will have a particular database to store the customer information. And from a Metro standpoint, they want to create a single application, a single truth for all these customers in the world. And we should be compliant with legislation that is all around the 127 countries Metro is in. So we have to just think about data as well. And it should be performant. So they want to have a golden record that is performant as well. Processes of the processing of this data should be performant as well. So what they have right now, or what they had, was lots of databases, no way of creating a golden record, no means of scaling. So if they have if they had, for instance, MediaMarkt, maybe 1 million customers a day, they weren't able to scale very much. And we have to make a solution, or we have to build a solution that was able to scale as much as possible. Even linear scaling should be possible. So, what was the request? Build one performant customer database. All these companies, all these databases should be included in one data store. And they have to and they have to create some golden record for all these this data that is so around. And you have the great possibility to scale. So, meaning I have to scale depending on load, but I also need to scale scale with the horizon. So if it's 8 o'clock in the morning in Hong Kong, I want to have more resources available in this particular area of the world to serve my customers fast. And if I'm in Düsseldorf, or Metro is their headquarters is, it's 8 o'clock right there, there should be resources available to scale there and serve this high available be performant for the German customers. So we have multi-data center setup as well. So, what does this mean for architecture? There are a few rules we have to apply. First of all, everything should be a service. And I mean microservice in the sense that everything should have its own database, everything is stateless. Those are typical rules we have to obey. Then we have certain protocols. If we want to do synchronous communication, we use HTTP. If we're using async, we use 0MQ, or we did use 0MQ, but we're currently using Kafka. And we have to run on a scalable platform. That means that the platform itself should have the ability to scale. And this is one of the solutions we use Kubernetes for this. And we should be able to run over multiple data centers. So we have this follow the sun principle. So we, what I just explained from, if it's in 8 o'clock in the morning in Hong Kong, we should perform it in Hong Kong. And we should be in a lower state or less performance state in Düsseldorf and so on in Düsseldorf. And we should be some sort of web skill. And web skill for us, we explained that we should be able to handle 1 million requests per second or more.
Why sort of?
Sorry?
Why sort of? Why not?
Web skill, you can explain it as a Google skill, and that's not applicable. So we describe this, we should be able to handle 1 million requests per second. And that's our arbitrary number we set. And everything should be delivered with continuous delivery and using DevOps or using DevOps principles. And that was my responsibility. Here's a nice global picture of the solution we have built. So what we did is we have all these old data sources and we use Apache Spark to put it in Cassandra and set out events to Kafka. And we have these Spark jobs that we deploy. These are actually Artifactory that one of the teams is creating. We have these microservices providing certain endpoints for the users to use, for instance, for creating for creating a customer. So that is building up for the new. We have a UI, and this all runs in Kubernetes, and we have a Spark, part of Spark, or we use Spark as a second architecture as well, the component as well. So, old habits. So, my responsibilities. I was hired to build up continuous delivery pipelines, and I had to do this for 3+ teams. We started out before with 3 teams, and my role was really to facilitate those teams in doing DevOps and continuous delivery. And what I had to do, my assignment was to create a uniform way of delivery. And by uniform means they still have containers, other teams are Spark jobs dependent on or a UI component. And the process should be uniform as much, should be uniform that all these solutions fit in this process. And I had to train a colleague, German colleague. So it's always great to help somebody gain knowledge and codecentric Germany. Codecentric Deutschland. It wasn't German, I was hired by codecentric Germany to do this, so. And we have to create a one-click to delivery or delivery to production solution as well. So we have to have a pipeline that was you can deploy something with one click. And also important, you should do it all with open source tools. There should be there are only certain tools were allowed for closed source. For instance, if you look at security checking. So what does this mean? What do we have to build? We have to support 3 teams that are building 40 different projects. Different teams, or one team could have 10 plus microservices in their development. They could develop 10 microservices or more. And per project, they could have 5 plus branches or more. So we use Git flow, and this means at the minimal you already have 3 branches. But we also have feature branches. And all these branches should have their own pipeline as well. So we should support this pattern. And we should be able to make any pipeline custom for any branch. So we have to have this flexibility of changing certain parts in the pipeline dependent what their needs are. For instance, if you're doing data migration, you want to maybe facilitate it in a certain branch, we should be able to do this or allow this. And we should guarantee uniformity over the teams. So the process is uniform. So what the tools are. Solution. So within the solution, I want to talk about the steps I took to reach this goal. And we set out a pretty ambitious goal for ourselves. I'm not sure who's familiar with the continuous delivery maturity matrix. Our goal is to be in the top segment, and even then we're not satisfied. And we want to somehow allow this model for trust in our software. So if we're taking steps, we're adding confidence to our software to eventually go to a point where we can deploy to production. And to simplify this model or this process like this, people can easily understand what we're doing. So, solution, uniform process. Abstract process that fits every team. Should be able to support different tool stacks. Support branching and releasing. And it should be repeatable, and we should be able to build fast. So if somebody breaks the build by checking in some Java, he forgot certain keyword that the class will eventually break, we should be failing within a few seconds. And up to 15 minutes, we should be able to get results back. We were able to do this. And the longest run we had in the pipeline was 5 minutes for a full run. So we're pretty whole pipeline within this 15-minute window, it was called. So, how does this process look? Now, this is the abstract process we eventually implemented, and we have based on in which branch you are you in a release branch, yes or no? Dependent on that, you follow a certain path through the process. So if you're releasing, for instance, security checks, this is something that is done. Or if you're not, for instance, doing a deployment step, or if you're not doing deploy to production, for instance, but the release step you will. So this abstract process, and for every step, we should be able to support different tool stacks. So this means if I build a Java application, for instance, I use Maven, and if I use, we're also having a lot of Node applications where we did have support for NPM, for instance. So we're able to fit the tooling right in that is necessary for this team, but keep this process abstract as possible and make it possible to switch out tooling. So what does this mean? For every branch, for every pipeline, for every branch in every project, we have a pipeline. We do automatic deployments for feature branches and development branches. For release branches, we create an artifact, and this artifact can then be deployed by manual pipeline. So it's also the difference between continuous delivery and continuous deployment. So continuous delivery is more about you have this manual step saying, hey, I want to deploy to production, and deployment, you will all do it automatically. Sorry?
A question?
Yeah, sure.
So there are probably a different number of feature branches at all time?
Yeah.
So how you deploy to different number of...
We use, we did a trick. We calculated the modulo of the Jira issue number, and we assigned a port number based on this modulo.
Port number.
Yeah, and we can use Kubernetes allows you to have about 10,000 ports or so assigned to a certain project, and we just choose one of these 10,000 ports.
It's really all feature branch.
Yeah, so we were able to deploy it all. That's really also an advantage if you're using Kubernetes, for instance. And we had a development that test Kubernetes cluster, and we had an acceptance and production cluster. So acceptance and production run on the same cluster. The only separation was that we had a certain block of ports that we use for acceptance and for production. And we should be able to have different type of deployments supported as well. So we did not only deploy to Kubernetes, but we also did deployments to Spark, for instance. So we wanted to have a new version of a Spark job, we had to be able to deploy to Spark. So we did some tricks with Jenkins. I will show you in the walkthrough. I will show you how we did this. That's pretty cool. We used JobDSL and BuildFlow. Who's familiar with JobDSL and BuildFlow? Yeah. A few years ago, they started with JobDSL. And JobDSL is a way to describe your job as code. And you're able to define your process as well with job DSL. At a certain point they knew it wasn't enough. So they introduced build flow. And build flow allows you to separate the actual jobs from the process. So in the job DSL you probably will define your jobs, your actual execution of these blocks are shown you in the uniform process. And with build flow, you describe the process itself. So, and we did some pretty neat stuff as well with rebuilding our pipeline. So we're able to, we had 40 plus projects times 5 plus branches. So we had 200-300 pipelines at any given time. We were able to rebuild it all within 5 minutes. If we had a bare Jenkins, a clean Jenkins installation, we were able to rebuild this all within 5 minutes with only one job. And we used the 3-stage rocket approach we thought of, and I will give you a short explanation. We had a list of repositories that was under our control. So there are a lot of projects within Metro, and we had about 40 in our control. And we made a manual list of these, and it's one-time job you had to do. And what we did is for every item in this list, we created some hierarchical structure to allow us to create for every branch within this project a build pipeline and a deploy pipeline. This build pipeline, it was aware in which branches was running on. We're heavily dependent on convention here, so for every feature we used feature dash, for instance. For every development branch we use development. And for every release branch we use release. And depending on which branch you are, we are able to create this deploy pipeline if it was necessary. So for feature branches and development branches, we were able to create, it was just a step in the automated process, so we're automatically deploying to the feature branch deployment and to the development branch. But for acceptance and production, we had a separate pipeline, or we generated a separate pipeline for this manual deployment.
Can I ask a question? So how does this differ from the multi-branch pipeline function you have in now?
It didn't exist yet.
No, okay.
It did exist, sorry, I will correct myself. It did exist, and it was part of workflow, the workflow plugin, and you had to pay for the enterprise license to get the workflow plugin. And that really contradicts what for one of my first slides I had to use open source tools to do it. But this is also one of the things I will talk about in my what happens next slide. Yeah, this is one thing that happens. Pipeline DSL came out and it really simplified this problem. And, So we also did some things. We had to set some conventions regarding source control. We had to enforce Git flow within the teams, or we had to adopt these principles of Git flow within the teams, and we had to restrict certain access to the branches. So a release branch somebody could never commit something to a release branch. This is done by Jenkins. We also did, for instance, every commit should have a direction. So these kinds of things we implemented to facilitate traceability. This is, and we even production and to the code the actual commit it belongs to. Now we had a setup of branches, and we really reacted on based on the name. So we use feature branch, or development branch, or release branch to build up this pipeline. And this is a global presentation of how we are. For a feature branch, for instance, we wanted to have fast people. People are developing. Some people are working on a feature branch together, and you don't want to have a long pipeline. You should have a feedback back in 30 seconds to a minute. Then you're finished with the feature, so you decide that you can branch it or you can merge it back to develop. So we had an extra step. We should do HTTP testing, for instance, and we decide this can take up from 1 minute to 3 minutes to execute. And if it was alright, we automatically deploy to the development slot. And then we're having a new version. So we are having a development or release pipeline. And this was the whole shebang. And it rolls out. Yeah.
So the ATD test, you do not do that on the feature branch. So is that true?
That's true.
So you could break your development branch if you check in a feature with possibly failing ATD test.
Yeah, but this is it's true, but it was a consideration between speed and consistency or quality, and we aren't missing any. We're still validating the quality in the end, but for time's sake, we choose to shorten the pipeline based on the branch you're in.
Did it often break?
Not really.
It happened.
Yeah, if you're aware, I'm not sure who is working in the microservice space, but one of the things I noticed is that you're really simplifying things you're doing. So you're not dependent anymore on other servers that may be included in some monolithic application. And this really reduced the size of the test set. And this ATTD testing, it's more, for me, it's how people are interacting with the system. So, in some cases, you may be only testing the UI here, but you may be also testing the constellation of services here. And I would say that this could even be, in some cases, be a separate project that is, testing all the projects together. But you will still execute it in every pipeline based on your changes you've made. So releasing is something quite difficult, I find out. Here's a list of tools, and I'm not sure if everybody is familiar with the releasing model of each of these tools, but they're all different. For instance, Maven is a really strange. If you look at other tools, they have a really strange version strategy. They use snapshot, for instance. And if we're going to Gradle, that isn't really a problem. But if you're using npm, they don't have a concept of any snapshot. You type in something and it is a new version. So we have to think of a way to uniformly version everything and be consistent with and same goes, for instance, for the order tagging. What are you going to use, for instance, if you're having a Maven project and this Maven project goes into a Docker container? How are you going to tag this Docker container? Is it with the dash snapshot, or are you using something else to? And this also brings up the problem of Git tagging. So this versioning, this is really a strange problem. By choosing, supporting multiple tools, you really have to think about how you're going to name your version. Artifacts. We did deployments of different kinds of artifacts. These are the artifacts we currently supported. We have Docker containers. So we have our own Docker repository, and we even split it up. We have a development and test Docker repository, and we have a production acceptance repository. And at some point, we did a handover to this new repository because of this is caused by Kubernetes, different Kubernetes clusters. So it should be able to access the Docker repositories. We have jars in Artifactory, so we had for Spark jobs. We had zips in Artifactory that were most of documentation sites we created that they had to be deployed. We also had stop the line principle. Who's familiar with stop the line principle? And who is really doing stop the line? This was really hard to enforce on the teams if they break something. My role was to implement the DevOps and not to, in some sense I was there for facilitation, but in the end they should be able to do this themselves. So this was really difficult to implement within the team, to have this discipline from something breaks down, figure it out, or the process is breaking down, figure it out, fix it, and improve upon these things and learn from it. If you're ever doing a continuous delivery implementation, spend some time on this.
Stop the line doesn't necessarily mean that something is broken, right? Everybody in the team
Yeah,
has the
it
power
even
to stop the line.
you can improve something, and we can do this maybe in half the time, for instance. This is really a reason for stop the line as well. We had also had one thing on our backlog that was data migration, and we were really in the we had it easy. We were a greenfield project, meaning we're not bound by any old architecture. We had these old databases, but we were not really limited by what these problems from architecture maybe from 20 years ago. So, but we thought about it, and we used the distributed log to solve this kind of problems. So, or mitigate in upfront these kind of problems. And we did some use of Liquibase for database version, but this was also too minimal. We really relied on this distributed log. So what we did is we have the concept of distributed log is it's an append only logs, and we all add events, and we react to these events if necessary, and we can roll out a new version starting, and this will react to the events starting at 0, and so on. It's really simplified some of our problems as well. So, delivery. We had all kinds of delivery strategies. First of all, we had delivery to Kubernetes. Whoever worked with Kubernetes, if you have a certain, there are a few concepts, if you get them, it's pretty easy. First of all, you have these pods. These are your applications. And they are offered in some sort of Amazon tools and auto-scaling groups. And you can, or replication controls, they're called in Kubernetes. And what we did was not deploy pods, we deployed replication controllers, saying, hey, I want this size of number of instances, or this number of instances rolled out to my Kubernetes cluster, and we had the concept of services. And services allows you to connect on any host in the Kubernetes cluster on a certain port to connect to this server. And we were in the position that we're not able to use Kubernetes 1.1, and it's really had a disadvantage for us, meaning that we don't have the ability to do L7 load balancing, meaning that we cannot set certain complex path, for instance. And then we had the delivery to Spark. Now that was really easy. That's just a copy of a jar file to a Spark cluster. Really simplified our problem as well. But we also had some difficulties. First of all, we had to deploy different branches. So all the feature branches have to have a port selected where they can deploy on. And if we want to run tests against these newly created pods or services, you have to get the support and use the support for testing. But we use this slide to determine our need for DevOps, or maybe our need for Ops. Our problems were pretty easy. So we were supported with the Kubernetes cluster. I was not responsible for running this cluster. Somebody else was. So I was able to just, like if you're running on Amazon, just create a web server on it or a database on it. I don't care. We were provided. So, but if you're going lower into the stack, your problems or your need for Ops or your Ops discipline within your team, the need for Ops discipline will become greater and greater. Even to the point if you're running, if you even are dependent on hardware in your Ops organization, you really have to think about, am I able to run, or am I able to do DevOps in the sense from, I have people that support me to do operation stuff, so helping out certain configuration for load balancers, or am I dependent on Ops people ordering servers and waiting, because the waiting game starts here. So if you want to work iteratively within a team and do DevOps, then this is becoming very hard. But we also had it easy with Spark, and this is really a simplified version of what we did. Was we have all these Lambda applications, and we just deployed it to Apache Spark. But now the cool stuff, where people get really excited, the coding examples. First of all, let me show our three-stage rocket. What we did was, first of all, if you look at the first stage of this rocket, we just had a list of items that were under our control, under our source control. And we had deployables These are things that we actually deployed to Kubernetes or to Spark, for instance. And we had components. Those are shared components between, for instance, if you have two microservices and they have both, and you have some REST-like or some modules for REST, for instance, or some extensions of the REST framework, we put them here as components. So we were able to differentiate between if something is deployable, we create a deployment step as well. But if something is a component, we only created a step that releases something to our factory. And we had some tool stacks as well. So we had a job that allows to Spark submits. So this was our first step in our rocket. Then we had our C jobs. Our C jobs were pretty great because we're really reliant on job DSL here. And the great thing about job DSL is that next that you can define your job using Jenkins DSL, you can also use Groovy to do certain programming into your on all these kind of interfaces you offer. For instance, what we did is we read this modules file we have created, and for every module we did something that create jobs for module, and we had some properties, and based on if something is a tool, for instance, or is deployable, we're able to create a certain kind of branch. And what we did is for every branch, we get this information from GitLab. GitLab offers a great API to just query. We were able to create something that is really appropriate for the branch you're on. So if something is a valid branch or is a tool, we did a certain step. And if it's deployable, we even create a deployable directory or a folder. And based on that, is it a Kubernetes deployable, yes or no? And we are able to just create certain certain pipelines that fit a certain model based on the information we get from GitLab, for instance, or from a modules file, and therefore we were able to create this three-stage rocket. Now, after we've done this, we create a pipeline file in every project, and I have an example project. For instance, this every project there was a convention that we read the pipeline directory. And this pipeline directory contained all the jobs and the process for this project. So we had a pipeline.groovy that was maybe a review, and we had a build flow set up. This was our process saying, hey, first we do a start, and then build our job ending on the start suffix. If it's a release job, we do some, we're getting some properties as well. If it's an image, if it's not a feature branch, we do some parallel stuff as well. And based on all, on which branch you are, this process is executed. In the first, the first slides, you have this uniform process, and this is the description of this process in code. and we're able to version this with our project in Git. It's pretty cool. And we're able to rebuild our pipelines based on what is in Git, and just say we just created a C job, and the C job will create everything for us. We also did Kubernetes deployments, pretty simple. We used replication controller, as I told before. So replication controllers creates instances on the Kubernetes cluster based on your needs, and we use services to access these servers or these pods from the outside world. One thing we learned is that we're instead of depending on tools and frameworks and things that people have built, were really dependent on scripting, bash scripting, and it really helped us out with solving certain problems. And it's one of the tips I want to give you. If a solution doesn't fit your needs, please look into bash scripting, because it's really going to solve your problems. This is how it looks in real life. So it's really simple. So for every team we have separate folders, and each folder contains the projects this team is working on. And for instance, we're able to rebuild everything with our seed of C jobs. So this is rebuild everything for every team.
So when do you have to execute it each time there's a new problem?
It's no. If we lose our configuration, if we lose our Jenkins pods, we only create a seed of C jobs.
This scanning, when does it happen? If I have a new repository?
There are C jobs per team as well, and if the team, it just adds a
in
this modules file. It's one of the first files I showed with the Git. If some team member adds the project, it automatically becomes under our control. But for our customer registration team, this means that we're creating jobs based on. They had a first pretty simple process and add a deployment folder, but other teams have a more extensive setup based on their needs. So, tips and tricks. These are the things I run into. These are the things that make it difficult. First of all, restrict the number of buildings. It's very hard to support npm and Gradle and SPT and Maven all together. It really makes it unnecessarily complex to. If you're in a position to limit the tools, please do. Start with versioning as soon as possible. We run into very difficult problem because we didn't think of versioning up front. And we noticed it when an actual release date for one of the teams came, and they were unable to release their software or create a new version of their software. And they had to refactor everything because the setup of the project wasn't correctly done. And this really made our life difficult. Restrict the number of artifacts you create. So we are in the support. We're able to limit this. So we had Docker containers coming out, and we had Spark jobs and some zips for containing documentation. And only use tools with API. And using tools with APIs has a great benefit if you want to interface certain, if you're having, for instance, a security tool, and you have to do some automated security tests. It's pretty handy if you have a tool that supports or has an API you can talk to. Say, just execute or give me a result in 5 minutes or so, or it really simplifies certain problems. And yeah, one thing we learned public-private key authentication. Really, instead of using, we authenticated with certificates to certain systems, and that really made our life easier. Instead of some systems went away after a couple of hours. They came up and they had new credentials set up in with using public-private key authentication. We're able to mitigate. And if we're building up such a process, really focus on delivery as soon as possible. Don't, what we ran into, we were running for 2 months. I was in the phase 0 phase in the project, and the phase 1, and we're starting to release in the end of phase 1, and then 2 months have passed, and that it really made it difficult to, we were running into problems too late. You really focus on delivery, then you run into these problems much earlier. So, but there are also our limitations, or the limitations in our setup. We weren't able to run or deploy load balancer configurations yet. We used F5 load balancing for it was before the Kubernetes cluster, and we weren't able to run or deploy these configurations for this load balancer. The combination of configurations or versions became huge. So there are 300 pipelines to manage, and for 2 people it was really too much to support it all. And have all this combination of tools, and so if you are able to keep the number of pipelines you're supporting small. One thing we ran into, Kubernetes, I don't know if they fix it already, but it's very hard to run it over multiple data centers. So we had 3 Kubernetes clusters for every data center. We had to do some tricks to duplicate certain services over these data centers. So I'm not sure what the current status of Kubernetes, if it's already possible. And and there was no shared network between these data centers. Annoyed as well, so because we're unable to use the sender for certain data rings. We had to do some tricks to sync up the data between these data centers. So if you're going to build a multi-data center setup, think of these kind of things beforehand. So, what has happened since I left the project? It was a few months ago, and a lot of it has happened. First of all, Jenkins 2 came out, and they, next to the changes they did to the interface, they had a great idea a move from a continuous integration product to a continuous delivery product. And with this pipeline DSL plugin, I only have to create a Jenkins file and place it in the root of my project folder, and it will take care of my problems, and really, really simplify all the things we already did to build up this uniform process. And so, if you're ever going to rebuild this kind of things, or if you want to build it yourself, look into the pipeline DSL files instead of build flow, for instance. Job DSL still is probably necessary for certain parts of your process, but pipeline DSL will really help to automate your process.